Hi everyone, my name is Peter. Welcome to my YouTube tutorial. And in this section, we are going to be looking at organic chemistry. And today's topic of interest is alkenes. So under alkenes, we are going to discuss our first objective, which is the degree of unsaturation. So before we go further into discussing of alkenes and their reactions, we have to understand what we mean by the word degree of unsaturation. And also we shall see how the number of pi bonds or presence of cyclic and acyclic structure affect or tell us the degree of unsaturation of a given alkenes. So now previously before you studied alkenes, you had to study the first functional group, which were alkenes, and we say that alkenes have a general formula. So the general formula of alkenes was CH2N plus 2. So now alkenes have a general formula of CnH2n. So meaning that we do not have a plus 2 on alkenes. So therefore, when an alkene loses 2 hydrogens, it either becomes an alkene or a cyclic alkane. So now, to determine the degree of unsaturation, degree of unsaturation of an alkene, what does it mean? It means that an alkene loses 2 hydrogens during the formation of a pi bond. So when we have one pi bond, it is equivalent to a loss of 2 hydrogens. And therefore, we shall say this molecule or this compound has a 1 degree of unsaturation. For example, if we look at a simplest alkene, which is if this is the general formula, so if my n is equals to 2, so we shall have C2H4. So this is ethene. So ethene is my simplest alkene. And when we draw the structure, we shall say that this is how ethene is written, and it has 1 pi bond. So therefore, ethene has 1 degree of unsaturation. Okay, so now let us look at if a compound has more than 1 degree of unsaturation, how does it look like? So now let us look at a compound like CH2 double bond CH, CH2 double bond CH2. So we have this compound. It has a double bond. If I'm to name this, this will be a 1, 3 is a diene. Then 1, 2, 3, 4. So that is butadiene or butadiene, or 1,3-dibutene. So now this compound has 2 pi bonds, which is equivalent to 4 hydrogens being lost from the general formula of an alkane. So therefore, we shall say that this compound has a 2 degree of unsaturation. Remember, if we are to refer back to the general formula, we always compare the degree of unsaturation to an alkane. So now, so if this is my general formula of an alkane, So if I'm to write the general structure of butane and alkane, that will be CH3, CH2, CH2, CH3. So now this compound has lost how many hydrogens to form this diene? So now if we count the number of hydrogens here, we have 1, 2, 3, 4, 5, 6. So this compound has 6 hydrogens and 4 carbons, whereas our butane has 4 hydrogens and has 4 carbons and 10 hydrogens. So meaning that this molecule has lost 4 hydrogens to form a diene. So therefore, remember we said that for a molecule to be called unsaturated, it has to lose 2 hydrogens. So now, if the molecule has lost 4 hydrogens, so that means it has a 2 degree of unsaturation. Okay, now, so since we've seen how a diene has 2 pi bonds and a degree of unsaturation of 2, how about if we have a compound which is cyclic and has a pi bond? For example, let me use cyclohexene. So now this compound is a cyclic structure. Remember, cyclic alkanes have a general formula. Cyclic alkanes have a general formula of CH2N. Their general formula resembles that of alkenes. And remember, alkenes have a degree of unsaturation of 1 if they have 1 pi bond. Now, this structure, cyclohexane alone has 1 degree of unsaturation. Now we have a pi bond within it. So 1 pi bond plus cyclic structure of cyclohexane gives us a 2 degree of unsaturation. So now we've seen how presence of a cyclic structure with a double bond or a pi bond increases the degree of unsaturation of a given compound. If I go further to incorporating more bonds, so I'll be having 2 pi bonds and 1 cyclic structure. So 2 pi bonds, 1 pi bond is equivalent to 1 degree of unsaturation. So now if I have 2, so that will be 2. And if I have is 1 cyclic structure, that will be equivalent to 1 degree of unsaturation, giving me a total of 3 degrees of unsaturation. So therefore, this is all I had for you as far as a degree of unsaturation is concerned. Thank you very much for watching. See you next time as we discuss further the reactions of alkanes. Bye for now.